In this lesson, we're going to talk about adding and subtracting polynomials. So first, let's talk about what a monomial is. So monomial is any single term, like a number, a variable, a product of numbers and variables. So like here, right, that's a 7, that's a monomial. That's an x is a monomial. Even this, negative 3x squared is a monomial. So any single term, compared to something that looks like this, 2 plus 3x, or like x plus y plus z, all these have more terms, so these are not monomials, and we'll talk about them more in a second. But any single term, no plus or minuses anywhere, that's a negative, not a minus. These are all monomials. So single term, mono means 1. Okay, next up, what's the degree of the monomial? It's like, what's the power of the monomial? So let's start here. Actually, I'm gonna make a new one up. 2w cubed. So the degree of this monomial right here will be the highest power, which is 3. So this is a third degree. Over here, there's no you don't see a power, but there's always a power of 1 if you don't see it. So this will be a first degree. 7, you don't see an x anywhere. There's no variable. So it's kind of like it's x to the 0 power. So this will be a 0th degree, also known as a constant. Right, when there's no variable, 0 degrees are known as a constant. And then I say this one for last. So in this case, you have 2 variables. So when you have 2 variables, you're supposed to add the powers. So add the degrees. So this will have a degree of 3. This will be a third degree. Because we have 2 x's and a y, so the total power of this term is 3. So third degree. This is a third degree, so this has a power of 3. First degree, and then no power, no variable, so 0, constant term. Okay, so we know what a monomial is. It's a single term. We know the degree of the monomial, so the power of it. So a polynomial is when you combine more than one monomial. So something like this, right? We're combining 2 monomials, so it's a polynomial, right? More than one. Same thing over here. This has 3 monomials together, so also known as a polynomial. There's fancier terms for this. This is also known as a binomial because there's 2 of them. This is also known as a trinomial because there's 2 of them. But in general, the collection of these things, all these types of things, are all called polynomials. Even the monomial, this is considered a polynomial. So these are polynomials. The degree of a polynomial, you just look for the highest degree of the monomial. So if we look at all these monomials separately, what are the highest one? That'll be the degree of the polynomial. So like over here, this will be a highest one we have is a 2. So this will be a second degree. Over here, the highest power is 1, so this will be a first degree. Over here, we have to look at all of them, right? This has a degree of 3. It's a third. This has a degree of 4. This has a degree of 0. This has a degree of 1. So this is a 4th degree polynomial because the highest power we have is 4. Okay, so let's try a couple more. Name each polynomial based on its degree and number of terms. So this only has 1 term, so we'll call this a monomial. And then the degree, there's a power of 1 here, and there's a 2, so put them together, you get 3. So it's a third degree. The next one would be, has 3 terms, so this is a trinomial. And the highest power, we have a power of 1, power of 1 here also, and a power of 2, because it's x and y. So this is the second degree. Okay. So the standard form of polynomials, we want to put in descending order. So if we go back up here, right, 2, 1, 1, that's in descending order, that's in standard form. If we look up here, this is not in standard form, right? It goes 3, 4, 0, 1. You got to rearrange it. So we want the highest power first, and then we go down in order. So if we want to write this polynomial in standard form, this has a power of 0, power of 3, and a power of 2. So we're going to put this one first. Negative 3x cubed plus 6x squared plus 7. Now keep in mind the power would is it positive or negative? It goes with the number in front of it. So here 3 is a negative, 7 is a positive, and 6 is a positive because of the value before it. So we can combine like terms with monomials now. So all we're going to do is we're going to add and subtract the exact same variables. So the exact same ones. So if I have a monomial here, we're just going to simplify it. And the only thing you could add are the ones that are exactly the same. So I could add the 4x squared with the negative x squared. And I could add the negative 3x with the positive 3x. So if you want, you can rearrange it. 4x squared, negative x squared. Again, notice that because the sign is the one in front of it, so the x squared is negative. And then we have a negative 3x and a positive 3x. Right, same idea. The sign in front of it. So this is so that this 3x is negative. When you subtract, remember this has there's like a 1 in front of this. So 4 minus 1 is 3x squared, and then these cancel each other out. If we try this one, same rule applies. The y cube is going to be added to the y cubes. The y is going to be added to the y's, and then that constant is by itself, right? There's no other constants there, no variables. So this add up like terms, we're going to do this a little faster. So this one with this one is 12, 5 plus 7, y cubed. And keep in mind, notice when I add it, I don't add the variables, right? Those just let me know which ones I could add together. That's all it is. It's like a matching game. I can match this one up with this one, add them up. I can match the y's with the y's, add them up. And I add those two, I got negative 3y. Oh, I can't see. Minus 2y. They're both negative, so anytime you're adding two signs in the same sign, you just add them up. So negative 3 minus another 2 is a negative 5. Right? If they're the same sign, you just add them. You get more of them. And then there's plus 7. So that's how you add a subtract like term. Let's do one more just to practice here. Okay, so here, all right, they want us to simplify. We're going to add up like terms and put it in standard form. Now, the parentheses actually don't mean much in this case. You could think about it like there's a 1 in front. And if you distribute the 1, well, you just get this. Right, that helps you do that. But honestly, in this case, there's nothing in front of the parentheses. It's like they're not there. So all we're going to do is add up like terms. So x squared is by itself. I can't do anything with that. I could add up the x's though. And the constant term is by itself also. So the only thing I could add up is these middle two. So I get 3x squared plus 1x, or this x, plus 9. Again, you don't really need to show the 1. Is that right? So all I can do is add the middle terms up. Same thing over here. Again, we're just going to do this one real quick. Only terms I could add up are the 5x and the 3x, and then negative 7 with the positive 7. Now, if there was a negative 1 here, if this was a negative, I would distribute the negative first. But since this is a plus, it's like distributing a 1 to both of them. So it doesn't really matter. So in this case, I'm going to get negative 2x squared plus 8x. And then that's it, because the negative 7 positive 7 cancel out. Notice I put it in standard form, right? Highest power is first. The power we're looking at, then we go 1, and then the power is 0. Power of 2, power of 1. So here we go. So we can subtract polynomials. So in this case, it really does matter to distribute this negative first, correct? Because negatives change everything. So this is a 1. We want to distribute this negative 1 to both of them. So that's going to become a positive x, and then negative 4. Over here, you could consider like a 1 in front, then distribute that, but really you're just going to get the same thing back. Then once you hear, you just add up like terms. So the 4x with the x, the constant term with the constant term, and the 3x squared is by itself. So you get 3x squared plus 5x minus 2. And so this is a trinomial, and it's in standard form, right? The highest power is here, and it has the highest power of 2. And that's the lesson.